Hi 43, we are going to look at energy changes today. There are two new terms for you to know, and they are exothermic and endothermic. When you see the word thermic, okay, you should think of heat, right? So we are going to see how heat energy is related to exothermic and endothermic shortly. On this slide, you will see the two lesson objectives. I want all of you to come back to this slide at the end of the lesson to read through the objectives again to see if you have truly understood the topic. I'm going to show you a very short video clip.
Hi, I've got a couple of demos loaded up and ready to go, and one of these is going to go ahead and give off heat, and the other one's going to have heat taken in. So I've got a beaker of water at room temperature. The red display shows that it's near 20 degrees C room temperature. And I'm going to lower the temperature, and I'm not going to do so electronically like with a freezer, and I'm not going to do it with ice. I'm going to dissolve a solid, which is actually going to promote an endothermic process. The solid is called ammonium nitrate, and I have the formula on the board, and I'll point that out to you in just a moment. What's going to happen is water molecules will surround this, and the reaction actually sucks in energy. So we're going...
Alright, so the thing is, there is a beaker of water over here, alright, and there is a thermometer here to measure the temperature of the water, and this guy is going to add in ammonium nitrate. Now, if you have forgotten how to write the chemical formula for ammonium nitrate, now this is the best time for you to revise your chemical formula and chemical equation. Alright? Now, anyway, the chemical formula for ammonium nitrate is NH4NO3. Over here, this is the register that actually display the temperature. So currently it's 22.3. I want you to watch very closely to the register the moment the ammonium nitrate is added to water.
Temperature decrease here. So as I tap this in and it's stirring, we're going to see the temperature decrease. So on a good day, it'll drop down to about 0 degrees C. So it looks like we've got 7, and it's continuing to drop. The driving force for this reaction is the dissolving. The ammonium and nitrate ions are being surrounded by water, and it's going to a state of more disorder, as we say, and it's making the reaction happen. But in the process, think of it as like an energy vortex. Heat from the outside, heat from the water are sucked in to make the reaction proceed. Oh, and very good, it keeps dropping at 5. There aren't too many of these reactions, so this is rather novel. I also give it the nickname of the cold pack reaction, because these first aid cold packs, these little plastic bags with an inside bag, are available at pharmacies, and what will happen is if somebody bumps themselves like in the playground, somebody might come running over with one of these cold packs. What they do is snap it, and it's mixing the water on the inside with the ammonium nitrate, and it's spontaneously going cold, as demonstrated. Another little process loaded up here is just a simple combustion. I have some methanol, which is a 1-carbon alcohol, and I'm going to spray some on the counter and just go ahead and light it on fire. And flames are given off, a sign that we have heat, and I'll give personal testimony. It's warm. We have yellow, orange, blue flames here. It's combusting, heat's given off. That energy that's given off as heat came from chemical energy to begin with. Bonds are being broken, which costs energy, but then new bonds are being made and energy is being released. Let me go ahead and show you the processes.
Allowed to try this in school. But basically what's happening is the guy actually poured methanol. Now methanol is a kind of alcohol, so it's also highly flammable. Alright? And this reaction is an example of the combustion reaction whereby a large amount of heat energy is given off. Right. Okay, back to the slides. Alright, let us try to dissect the video. In the first reaction, when you dissolve ammonium nitrate in a beaker of water, alright, you realize there is a decrease in temperature. Now there is something that I'm I need to emphasize over here. Okay, let's be very clear. When we talk about temperature, in this case, in this context, we are referring to the temperature of the That's right, we are referring to the temperature of the surrounding. Okay, please get this clear. Alright, the decrease in temperature is due to the fact that heat energy was taken in from the surrounding, which explain why there is a decrease in temperature. Now, we call this endothermic reaction. Okay, how do you remember? Okay, you see the word N-E-N? Okay, this is how I remember. Enter, E-N, enter. That means to say the heat energy enters the system. Heat energy is taken in. Heat energy is absorbed from the surrounding. Okay, so we call this endothermic reaction. On the other hand, for the second reaction, we have combustion, right? So for combustion, there is an increase in temperature. Again, we are referring to the surrounding temperature, right? We are referring to the temperature of the surrounding, okay? And this increase is due to the fact that heat energy was given off to the surrounding during combustion. So for this kind of reaction, we call it exothermic reaction. Again, how do you remember? Right? E X I T, exit. Heat energy exit from the system. Heat energy was given out, and therefore there is a rise in the surrounding temperature. We call this exothermic reaction. Okay, so you have just seen that heat energy is taken in during a physical process, such as when ammonium nitrate dissolves in water. Heat energy may also be given out during a chemical reaction, such as during combustion or when sodium hydroxide reacts with hydrochloric acid. Now, sodium hydroxide is an alkali. When alkali reacts with acid, right, you have a neutralization reaction. And usually for neutralization reaction, heat energy is given off. Okay, I believe a lot of you have personal experiences with this, right? During our practical session, some of you mentioned that the test tube actually became hotter and hotter. Now, that was because the reaction was exothermic. Heat energy was given off to the surrounding, therefore the test tube became warmer and warmer. Right, let me give you a very quick summary. Alright, imagine you have a box and then in the box you have a circle. The circle represents the system. The system is where the reaction is taking place. Outside of the system you have surrounding. Right, so when the system gives out heat energy, that means to say the temperature of the surrounding rises. So this reaction we call it exothermic. That means to say heat energy is given out. On the other hand, when the system takes in heat energy from the surrounding, temperature of the surrounding drops. So this we call it endothermic reaction, right? Heat energy enters the system. Okay. Now, if you look at this section, you can actually find this in your lesson notes. I'm going to draw a connection between kinetic particle theory and this topic on energy changes. Now recall, when the ice melts to become water, right, during the melting process, heat energy is taken in, am I right? So the particles in the ice, they actually gain heat energy from the surrounding. Therefore, there is an overall drop in the temperature of the environment. So for this reaction, we actually call it the endothermic reaction, because heat energy actually enters the system, right? The particles gain heat energy from the surrounding. Okay, on the other hand, during the freezing process, okay, for example, when water freezes to become ice, the particles in the water, they will actually lose the heat energy to the surrounding. Okay, therefore there is a rise in the temperature of the surrounding. So for this, we call it exothermic reaction, right? So the heat energy, all right, exit the system. That means the particles, they actually lose the heat energy to the surrounding. Okay, now introduction. You should be well aware that we cannot create nor destroy energy, but we can actually convert energy from one form to another. Second point is very important. Energy changes occur in chemical reaction as well as physical processes. Remember when we dissolve ammonium nitrate in water? This reaction is a physical reaction, but there is a change in heat, right? There is a change in heat energy, right? Heat energy is actually taken in from the surrounding. Chemical reaction usually involves a heat change, and the heat change results in temperature rise or temperature drop.